If you've studied capital budgeting, you know that NPV and IRR, that is net present value and internal rate of return, are the two primary methods we use for evaluating a project. And you probably also know that one way we interpret internal rate of return is that it's the interest rate that makes net present value equal to zero. So I have an NPV equation here where I have cash flows for n periods, each one discounted based on when it's received, and then I subtract out the cost. And if I find the interest rate that makes this equal to zero, I've found the internal rate of return. Another way to think of it is it's the interest rate that makes the present value of these cash flows equal to the cost. So here I have a project that cost 80, returns 15 for the first 9 years, and then 34 in the final period. And that larger cash flow in the last year could be, the return of salvage value, so selling off the equipment. And if we want to calculate IRR, we can just use this function in Excel, equals IRR, and I'm just going to highlight these cells here, and I get 15%. We can check and calculate the NPV using that interest rate and see if it's about zero. So I'm going to say equals NPV, and I'm going to use the 15%, and I'm going to say it's these cash flows. Now keep in mind, when you use the NPV function in Excel, it doesn't calculate NPV. It calculates the present value of the cash flow. So it starts discounting the first cash flow, and we don't want to discount this one. So you only want to highlight these cash flows starting in year one and then subtract out the cost later. So I'm going to add the cost because it's a negative number, and I get approximately zero. So that's just a rounding error. Okay, I couldn't make up a number that came out exactly correct here. So over here, I have something that you may also have seen, the NPV profile. That is, this is the NPV for different interest rates. Interest rates down here on the x-axis and NPV on the y-axis. And all I did was I computed NPV, and I put in the equation for NPV, but I used, instead of 15%, I used the interest rates that were here. So each time I copy down, it changes the interest rate, and you can see as the interest rate goes up, the NPV goes down. And where this intersects the x-axis is where we have IRR. So this is the traditional presentation of internal rate of return. I want to give you a little different perspective. You can think of IRR as the rate that that an amortizing loan will be paid off in that final period. So here I have the same beginning balance. Okay, say I borrowed $80 and I'm going to get these payments or these cash flows. And if I have the right interest rate here, the ending balance is going to be about zero. So that is, I've borrowed this amount, I receive these cash flows, and this is going to pay off the loan based on the interest rate. So what's the interest here? The interest is going to be, let's start with the 15%. So it's going to be this, and let me make sure I lock the cell here, so when I copy it down, it stays at that 15% times the beginning balance. And I get $12 here. How much principal is paid off? It's the payment minus the interest. So I'm going to say equals the payment minus the interest. And then the ending balance is going to equal the beginning balance minus the amount of principal that's paid off. And then our new beginning balance is going to be our old ending balance, our ending balance in the previous period. So I'm going to highlight that, and I can hopefully copy down some of these cells here. And you can see the balance keeps going down. So let me just copy this down all the way down to year 10. And I'm going to copy this all the way down. And what do we see? We see at the end of the period, okay, or the end of the project, the balance is essentially zero. So you can see at 15%, these cash flows covered this $80 cost. Let's take a look and see what happens if the interest rate were higher. So you can think of this as the NPV at the end of the project is zero. So here, if the IRR were higher, what would happen? We'd still have a balance here. That is, we would have earned a lot of interest here, and we would have a positive NPV. If we had an interest rate here, let's say that is 10%, you can see that we don't pay off the loan. It turns out that in year 10, we still have a pretty large balance, right? So this is going to be a project that's not good. So it's a little different perspective from what you're used to seeing. But if the IRR is the one that makes NPV equal to zero, it's also the interest rate that makes this amortizing loan pay off the total balance. That is, these cash flows exactly pay this off. All right. And if you have a higher interest rate, unlike a mortgage where a higher interest rate would mean you still owe money at the end, here you're actually going to have money because you're going to be earning a return that's sufficient to help us wind up with money at the end. Remember, this is the return you're getting. This is the stuff you're getting back. So you're not really paying off a loan, but it's a little different perspective to think about it. That if you have an interest rate that's too low, right, you're going to have a negative balance at the end. And if you have an interest rate that's higher, you're actually going to have money left over at the end. So I hope you found this useful, and thanks for watching.